Express 2 sine theta minus 1.5 cos theta in the form r sine theta minus alpha, where r is greater than 0, alpha is between 0 and pi over 2, and I need to give the value of alpha to 4 decimal places. So first, let's use the formula from your formula booklet for r, or for sine a minus b. In your formula booklet, this is sine a cos b minus cos a sine b. So in this case, we have sine theta minus alpha. So that's going to be sine theta cos alpha minus cos theta sine alpha. But we are also timesing by r. So times this by r, times this by r, times this by r, timesing both sides of this identity by r. I am now going to compare that to the 2 sine theta minus 1.5 cos theta. So let's compare that to 2 sine theta minus 1.5 cos theta. So what value of r and theta do I need to have here? Sorry, what values of r and alpha do I need to have here and here, at the front here and here, that are going to make this equal to this identity? So let's see, I've got a sine theta there and a sine theta there. So that means that my r cos alpha would have to equal 2. Similarly, over here, I've got a cos theta here and a cos theta there. So that means that my r sine alpha is going to have to equal 1.5. Right, let me just divide through by r here so I can see my trigonometric ratios a bit clearer. So if I had a right-angled triangle where this angle here was alpha, then the adjacent side of the triangle would be 2, and the hypotenuse would be r, and the opposite would be 1.5. Remember that I know that the cos is equal to the adjacent divided by the hypotenuse, and the sine is equal to the opposite divided by the hypotenuse. That allows me to work out r using Pythagoras. So I find that r is 2.5. It also allows me to work out alpha, and there's different ways you can do this, but I'm going to do tan. Tan alpha equals the opposite, which is 1.5, divided by the adjacent, which is 2. If I do tan inverse of both sides, then I find that alpha to 4 decimal places is 0.6435. So I have found that my r would have to be 2.5, and my alpha is going to have to be 0.6435 in order for these to be the same thing. So that is part A of this question. I have just shown that 2 sine theta minus 1.5 cos theta is the same thing, is identical to 4 decimal places of 2.5 sine theta minus 0.6435. Part B, find the maximum. So instead of finding the maximum of this, it's obviously going to be much easier for me to work out the maximum of this. what I found in part A. Now, I know, if I just focus on the sine part first, I know that the biggest that can be, the biggest that sine can be, remember sine looks like this, the biggest that sine can be is 1. So the biggest that 2.5 multiplied by the sine can be will be 2.5 times 1, or just 2.5. That's the maximum that this can be. Part II, find the value of theta at which this maximum occurs. Well, I can see here that the maximum for sine occurs when the angle is pi over 2. Which means that this on the inside here would have to equal pi over 2. So, theta minus 0.6435 would have to equal pi over 2 in order to get that maximum. So I can have sine of pi over 2 is equal to 1 and timesing by the 2.5 to get the maximum of 2.5. So add the 0.6435 to the pi over 2 and we will get the answer, which is 2.21. So that is my answer to part 2 of this question. Right, moving on to part C. Tom models the height of seawater h meters on a particular day by the equation h equals 6 plus 2 sine 4 pi t over 25 minus 1.5 cos 4 pi t over 25. Right, so first of all, let's just look at that carefully because I recognise some of this. Let's compare it to what we did previously. I've got the 2 sine something there, 2 sine something here, the minus 1.5 cos, minus 1.5 cos. This is exactly what we've been working with in the previous parts of the question. The only difference here is instead of the theta on the inside, I've got 4 pi t over 25. The other difference here is I've got a plus 6 at the front. So that means then that I can rewrite this equation as being h equals the 6. I've got the plus 6 at the front. Then, instead of the 2 sine minus 1.5 cos, I can write 2.5 sine 4 pi t over 25 minus 0.6435. So just to repeat, all I've done there, I've kept the 6 at the front, nothing I'm going to do with that. But then I've rewritten this as this, just replacing the theta with the 4 pi t over 25, because the theta is 4 pi t over 25. Okay, right, part C. Calculate the maximum value of h predicted by this model. So h max, what's the biggest that this could be? So 6 plus 2.5 times sine of the 4 pi t over 25 minus 0.6435. Well, the biggest that the sine can be, the biggest that this whole thing here can be, is 1. Same logic as we were using in part B. The biggest that can be is 1. So therefore, the biggest that all of this can be is 2.5 times 1. plus the 6 at the front. So 6 plus 2.5 times 1, which is 8.5 meters. That is the maximum value of height. I now need to find the value of t when that maximum occurs. Well, remember that the maximum of sine occurs when the angle is pi over 2. So I'm going to say that 4 pi t over 25 minus 0.6435 equals pi over 2. Because if this equals pi over 2, then I will have sine of pi over 2, which would be 1, times the 2.5 plus the 6 gives me the 8.5. So I will now add the 0.6435 to the pi over 2. I am then going to multiply by the 25, and I am then going to divide by the 4 pi. So whatever my answer was, multiply by that 25, divide by the 4 pi, and I find two decimal places that it is 4.41. And note, this is hours after midday. Right, finally, let's move on to part D of this question. Calculate to the nearest minute the times when the height of the seawater is predicted by this model to be 7 meters. So let's write the model down. The model was h equals 6 plus 2.5. Actually, the volume. H equals 6 plus 2.5 sine 4 pi t over 25 minus 0.6435. So if the height's going to be 7, let me replace the height with 7. And I've got this equation to solve. First, I'll subtract the 6 from both sides. The 7 take away the 6 is 1. I'm then going to divide both sides by the 2.5. This will now allow me to do sine inverse. So 4 pi t over 25 minus 0.6435 is equal to sine inverse of 1 over 2.5. Which gives either 0.4115 or, and it's really important to remember, notice the question says the times plural. There will be more than one answer to this. So let me just draw a quick sine graph to see when else the sine graph is equal to 1 over 2.5. Oops. So there is one solution here, there will be another solution here. That's my 0.4115. So this is going to be 0.4115. So I need to do pi, take away 0.4115, which gives 2.7301. So these are my two possible solutions to this. I am now going to add my 0.6435 to both of those. So 4 pi t over 25 will be equal . So when I add it to the 2.7301, I get 3.3736. When I add it to the 0.4115, I get 1.055. I am now going to times both of those by the 25, and then I will divide both of those by the 4 pi. So let me do that all in one go. So timesing by 25, divide by 4 pi. So my first answer is 2.099 hours, or the second answer is 6.7116. Those are the values of t. I need to give the times to the nearest minute. Remember that t is the hours after midday. So this is 2 hours after midday, which would be 2 o'clock. And how many minutes is that? Well, to work that out, let me just do a quick calculation. If I do 0.099 times that by 60, that's going to tell me how many minutes that is. That's 6 minutes to the nearest minute. So 2 hours and 6 minutes after midday will be 2:06. Or this is 6 hours. Then to work out what the 0.7116 is in minutes. Again, times that by 60, and I find that that is 43 minutes. So 6 hours and 43 minutes after midday would be 1843. And those are the two times where the height of the seawater is predicted to be 7 meters.